All right, so we're still talking about systems here for the next two slides. And we can think of anything, okay, so a disturbance. So here we are. We're on a slide that says systems exhibit fluctuations. And so nothing occurs in a vacuum, lives in a vacuum, right? Everything is interacting with each other. All this stuff is interacting together, but sometimes you have a major interaction. So if you go over here somewhere, I don't know where, but someplace where they're building a shopping center, and you say, oh, that used to be, I played in those woods that were there. They're not there anymore. They're building a shopping center, right? Now that's a disturbance. Or maybe a pioneer family came in and they cleared, you said, my ancestors, this was all virgin forest. And my ancestors cleared this 60 acres, and we've been making our living milking cows for the last 100 years. But what's happened? It's not that easy to make a living milking cows anymore. There's nothing wrong with it. It's a really interesting business, but it's not that easy. So a lot of these farmers are going out of business. And so what happens to that farm? Well, if they say, oh, we love the farm, so we're not milking cows or do anything with it, but we're just going to keep it in the keep the property in the family. We love having it. And so what happens to it? Does it stay a field? It becomes a forest. Even though it's been 100 years since your family cleared the forest, it will go back to a forest, right? If you don't mess with it for a long time, for a few hundred years, it will go back to a forest in this area. That's pretty typical, right? And so we have something called, we said a disturbance is a major change to the system. But then we have something called resilience. And now resilience is the ability to return to the previous condition after a disturbance. See, that's one of these are some definitions you need to know, right? So we had said we have a disturbance. It's fluctuations in the system. It's where something has changed. And resilience is the ability to go back. Now, in this area, and that's the reason I used the forest example, is in this area, if you cut the forest and then you leave it alone, it'll go back. It has a high level of resilience. That particular, the oak hickory forest we have around here has a high level of resilience. What about the tropical rainforest? I know you say, I don't know anything about tropical rainforest. Of course you don't. That's why you're in this class. But tropical rainforest won't do that. It's because it's so hot and there's so much water, the nutrients get washed away. All of the nutrients are in the life. If you go in there and you cut down a tropical rainforest and then you leave it alone, it stays dirt. It doesn't go back. It has low resilience. It requires, so tropical rainforests are an example of a forest because of the high temperature and the massive amounts of rain. The nutrients get washed away. So you have this nutrient poor soil that couldn't possibly support a forest. And so that's an example of a low resilience ecosystem. Okay. So we had disturbances, resilience, and what happened, we had said, if in that tropical rainforest you cut it like that, and you then leave it alone, it doesn't go back to a tropical rainforest, it goes to a new normal, dirt. right? Or maybe some small amounts of low nutrient plants, but it's kind of a disaster for the tropical rainforest. And so that is what we call a state shift. Remember, we had said these reservoirs, the plant communities, the deer, the carbon dioxide in the atmosphere, these were all state variables. Well, when those change, as in the tropical rainforest that is low resilience, going from a tropical rainforest to something else, that is what we call a state shift. So the world changed. Okay. So in some cases, we have something called, to really change gears with the next slide, we talk about emergent properties for an area, for an ecosystem. So I lived in New England for 5 years, 5 or 6, 7 years, I don't know. I lived in Gloucester, and it's a really, and if you look at that latitude, Boston kind of a latitude, it ends up Gloucester is quite different from even Boston or certainly Western Massachusetts. And the reason for that is the ocean. The ocean changes the environment. And the reason for that is water has what we call a high heat capacity. And so what that means is it takes it a long time to warm up, and then it cools slowly. So when I lived up there, my sister was coming to visit me from Richmond, Virginia. And she was coming in June. And I told her, make sure you bring long pants and sweaters. Now, have you ever been to Richmond in June? It's not long pants and sweater weather. No. It is shorts and bikinis and swimsuit time. But she didn't believe me. She came up there. It was cold as heck. And we even went up to southern Maine to LL Bean, and it was snowing in June. And this is an emergent property. And what is it? What is different? What's causing this is the seasons are delayed because of the cold ocean. So the cold ocean produces a difference in the properties of the system. So, and water is one of the things that has a major, that often is involved in emergent properties. So water acts to stabilize temperature and humidity and to add, it says add to regional biodiversity. So you get a different world. It's making reference to a wetland. I've also lived in West Tennessee where you had these kind of wetlands, which they're really pretty cool. They're flooded forest areas, really, really interesting areas. All right, I'm going to stop right here, and we will come back, and we're going to really change gears. I told you, Chapter 2, we cover a whole lot of stuff, science. Well, holy cow. We've talked a little bit about ecology. Now we're going to talk a little bit about everyone's favorite, chemistry. Yeah, yep, that's next. Hang on.